Circumference and area of a circle are need-to-know formulas. You have to memorize these things. You're going to be tested on them several times during high school. So let's use these in this problem right here. It says there's a foam circle with circumference 54. What's the area? Well, use these equations. So if the circumference, 2 pi r, equals 54, then that means r equals 54 divided by 2 pi. And that's going to be, let's see, 54 divided by 2 divided by pi, 27 divided by pi is 8.59436. Okay, I use lots of decimals because I don't like making rounding errors. Now area is going to be pi times r squared. What's r? Well, it's that thing we just found. So you square that thing, and then you multiply it by pi, and you have your area, which is about 232 square units. That's how you go from circumference to area. You find radius first. Now, let's talk about what a sector is. This is when you have a circle and you cut out a portion of it. In this case, I'm cutting out 103 degrees. I'm just taking that and throwing it away. Okay, so let's get rid of this section of the circle. That's gone now. And I want to know what is the arc length of the portion that remains. Well, this is easy if you know what percentages are. The percentage of the circle that remains is this angle divided by 360. And this angle right here is 257 degrees. It's the difference between 360 and 103. So my percentage, I can write it this way, equals 257 degrees, that's the portion left, divided by 360, that was the original. Okay, so 257 divided by 360 is 0.7139. So I'm going to take that and I'm going to multiply that by the circumference of 54. So 0.7139 times 54 gives me an arc length of 38.55. If you're following along and you're getting the same numbers as I am, great. You know what you're doing. The area of this sector is 0.7139 times the area up here, 232. So it's that percentage of a full circle, which gives me 165.6 roughly. Okay, so that's the first sections. Now this last part, I think this is the hardest part of the question. And what you really have to do here is you have to remember, here's your two formulas. C equals 2 pi r. A equals pi r squared. So you can see that if my ratio of small c to large c is 0.7, right? The larger circle has a bigger circumference. Then that means small r over large R is also equal to 0.7 because this is a linear equation. That means any change you make to R or C is going to be proportional to the other one. Now, it's different for area because the area equation has an R squared term. That means small area over large area is going to be equal to small radius divided by large radius squared, which is 0.7 squared, which is 0.49. Now, that would be the answer if they were asking for the ratio of small to large. They're asking for the ratio of the large to the small, which just means you have to flip this fraction over and take the reciprocal of it. So my answer here is going to be large area over small area equals 1 divided by 0.49 or 0.7 squared. And my calculator says 1 divided by 0.49, it's going to be about 2. Yeah, 2.05. That's the ratio of the area of the large one compared to the area of the small one.